Okay, welcome back. What we're doing in this video is I'm going to take you through some examples in how we use these equations of motion, the suvat equations. Sorry, by the way, I just noticed in a previous video I had this annoying little thing stuck in the corner there of the camera. Yeah, I'm just not going to film the video again. Okay, apologies for that. Okay, I didn't mean to have anything to be annoying there, right in your way. Right, here we go. An example of how to use the kinematics formulae. So a cyclist, quite a few of these, you'll notice in the questions that come up in mechanics, a cyclist travelling on a straight road accelerates constantly from a rate of, from a velocity of 4 meters per second to a velocity of 7.5 meters per second in 40 seconds. Okay. Now what I do is, before I answer these questions, I'll write down the information I'm given in terms of SU, V, A and T, in terms of the suvat to be able to use the formulae. So initial velocity will be 4. Okay, I tend to put units on as well. You don't need to, but I tend to. Okay, so initially the velocity is 4, and then the final velocity V is 7.5 meters per second, and that's done in a 40-second time period. So over 40 seconds. I tend to write seconds or an abbreviation, because if I write 40s, it might look like 405. Yeah. So anyway, there we go. Then it's a case of picking out the right formula. Okay. Now I'm going to emphasise that these questions are always using constant acceleration. The suvat formulae work for constant acceleration only. If the acceleration is not constant, you've got to use calculus, okay, or some other method, okay. But you'll be told that it's constant acceleration, or you have to assume it's constant acceleration, or if it's not, if the acceleration changes partway through the motion in M1, you've got to find another way of actually dealing with that. Okay, but there'll be an example somewhere down the line on that. What you've got to do is pick out the correct formula that you can use to solve the problem. We need to find the distance, so effectively the displacement, okay, which is the distance that she's travelled from starting point in this case. And I'm going to pick out the equation 1/2 u plus vt. These equations are not given in a formula book, so you do have to memorise them. So you've got to be quick at picking them out. Okay? You've got to find which one uses. And incidentally, when you've got 3 pieces of known information, you can generally pick out an equation to work out a fourth, okay? And then more if needed. It's then just a case of substituting these values in. So u is 4, v is 7.5, and t is 40. Okay? And then I suggest you pick up a calculator and work out what that actually is. Yeah, I'm sure you could do it without a calculator, but speed is of the essence, particularly in an exam. I'd advise writing units, because all questions are related to the real world. So 230 meters. That's part A. B, the acceleration. So we've got to find what the acceleration is. And what I'm going to do for this one is I'm going to go back to the original information given. There's a reason for that, and I'll come back to that in a couple of minutes. And I'll see which formula I could use to find acceleration, and I'm going to pick out this one, v equals u, let's try that again, u plus at, and I can substitute these and rearrange it to get what I want. So I've got 7.5 is v, I've got 4 is u, 4 is u, and then a times t, so that's 40, a. And I can rearrange that, so 3.5 is equal to 40a. And the acceleration a will be 3.5 over 40. Okay, 3.5 divided by 40, that's 7/80ths, but the done thing in mechanics is to use decimal, 0.0875. And the units there, meters per second squared. Okay. Now, you may have picked out a different formula to be able to use this. Okay, so for example, having found s, okay, you might have chosen this one, s equals ut plus 1/2 at squared. Okay, and if you substitute in those values, 230 is equal to 4 times by 40, added to 1/2, and then the unknown there, of course, is a, isn't it? So I'll put it there, and then multiplied by t squared, which is 40 squared. Of course, you could use that, rearrange it, and you get the same answer. Okay. However, here's the thing: if this answer was wrong, then this answer is going to be wrong as well, isn't it? Okay, because if you use that value there and that value is not 230, say for sake of argument it's 240 because you made a mistake somewhere. This answer will be wrong as well. So my advice is, if you can, go back to the original information given to you in a question and pick out a formula to use, because you've just got more chances of success that way. Okay? Even if you're really sure you've got that right, try and use the original values if you can. Okay, just increases your likelihood of success. Okay, so that's the reason why I preferred the V equals U plus AT formula in that one. Right, that's our first example. Another one coming right up. Okay, next example. This has been pre-typed. Hope you can read it okay. It's an older one of my examples. I just couldn't bother to retype it. So a train moves along a straight track. Again, what I said about the constant acceleration. Okay. 3 telegraph poles are set at equal intervals beside the track, points A, B and C. AB is 50, BC is 50 metres as well. The front of the train A passes at speed 22.5 metres per second, and 2 seconds later it passes B. Find all of these. A lot going on. Yeah, a lot going on. You've got to be able to visualise this, or if you want, just set up a quick diagram showing what's happening. Okay. So here you've got the straight track that the train is travelling along, and here you've got point A, and then equally dispersed you've got these telegraph poles. Some will mark points B and C there, and they're each 50 metres in distance. Okay? So that just helps with your visualisation of what's going on. The train is travelling along, passes point A, then passes B, then passes C. Okay? We know that it's 2 seconds between here and here. We don't know how long from here to here. Okay? And we know that when they pass A, they're doing so at the speed of 22.5 metres per second. We don't know the speed of here and here, and they are speeding up, they're accelerating. So that's what's going on. We're going to find the acceleration. Okay, so the first job is find the acceleration. So writing down the information we're given. So what we need to do is, well, obviously I think the U we're going to use is 22.5 metres per second. Now we're told something about the time. 2 seconds later it passes B. So what that means is we're going to have to consider the motion from A to B. All right. So if we're using 2 seconds, that means from A to B. So the displacement we use is going to be 50. That's important, because if we were considering from A to C, the displacement would be 100, but we don't know the time taken. And we don't know anything else, okay? You need 3 bits of information to be able to use a formula, okay? So find the acceleration. So for that one, I think we'll use this, aren't we? S equals U, T plus 1/2 AT squared, okay? And here revealed should be our answer, because I'm working. Okay, so the displacement 50, UT, so 22.5 times 2, okay? And then half AT squared. So this is not nicely typed up, okay? It's a really, really old one. I've come a long way since then. Half AT squared times by 4, okay? If you rearrange that, look, this is not a lesson how to rearrange formally, okay? You can do it yourself. If you rearrange that, you should get A is 2.5 meters per second squared, okay? So that's the first bit. We've worked out what A now is. Second part, find the speed of the front of the train when it passes C, okay? It's important that we talk about the front of the train, because if that's the front of the train, this might be the rear of the train, because it's speeding up. Notice when the rear of the train hits it, the front of the train is there. It's already going even faster. So that's why they're emphasising the front of the train, okay? When it passes C. But this time what we need to do is we need to consider the motion from A to C, okay? There's a reason why we're doing that. We'll write down the information. It's because we know more things that are going on starting from A. So for example, we know at point A, it passes at 22.5 metres per second. So we know U is 22.5 metres per second. The displacement this time is going to be 100, because it's from A to C. And what's the other bit of information we can use? Well, we're going to have to use this bit here that we've just worked out, okay? Now this is constant acceleration, which means the train will constantly accelerate at the same rate all the way along. So you can assume that the acceleration from A to B, from B to C, from A to C is all 2.5. Okay, so A equals 2.5 meters per second squared. And we need to find the speed when it passes C. So we need to find what V is, don't we? So for that one, I'm going to suggest V squared is equal to U squared plus 2AS. Okay, and this is what we get when we substitute in. So V squared is the unknown, U squared, 22.5 squared, plus 2 times A times S, 2 times 2.5 times 100. Okay. Now, when you find your answer, obviously, you take the positive square root, okay, which is 31.7. Okay. I'm hoping the word obvious makes sense because the velocity is not negative, it's speeding up again. Round it appropriately, 31.7, 32 will actually do. My advice is write down full answer and then just round it appropriately as well. This bit, the time that elapses from the instant the front of the train passes B to the instant passes C. Okay. Now, what I'm going to do is I'm going to suggest you do the motion from A to C again and find the time taken. Okay. Why? You might be thinking, well, hang on, we just need to know what's going from here to here, don't we? Yes, you do, but you know that this bit here takes 2 seconds. So if you can work out the time taken from A to C, you can then just subtract the 2 seconds and do it that way. It's kind of easier because we've got a lot more information about A to C because I've just written it all here. But all of this bit here, okay, that is from A to C. Okay? And we've got something else we can use, V. So we've got loads of different information now that we can use from A to C to just work out what the time taken is. I generally prefer, has to be said, V equals U plus AT, because then you can use the V you've worked out, the U from that, A there, and T, rearrange it. Okay. You can use S equals UT plus half AT squared. Okay. The disadvantage of that is that you've got the 2 variables of T that you're going to have to use. Okay. I'm just going to look to see what was being done here. Yeah. There we go. Yeah, as I thought, the V equals U plus AT. Okay, so just work that one out. Yeah, so V 31.7. Use the exact value, so don't round it to 31.7 or 32. Use the exact value found when you square root this, and then 22.5 plus 2.5t. Value of t is 3.69. As I said, you would subtract 3.6. 2 from 3.69, so you get 1.69 seconds. Okay, you can see there's an alternative approach to this as well. That's the one I mentioned, S equals UT plus half AT squared. I don't recommend that purely because it's a quadratic, and when you solve it, it's just a little bit longer. That's all. But there we go. That's that one. I'm hoping you found that one very useful. Okay, thanks for watching. Okay, I've got one more example for you. This throws up some really nice things. Okay, so a particle. Remember what a particle is? Because it's so small that the dimensions can be negligible. You can just draw it as a point. Okay, is moving a straight horizontal line with constant deceleration of 4 meters per second squared. At time t equals 0, the particle passes through point O, often called the origin, with velocity 13 meters per second, travelling towards point A, where OA is 20 meters. Okay, let me just set this up for you. Okay, try and imagine that this is a horizontal axis, call it the x-axis if you want. Okay, and that the origin is, say, there. Obviously, this is what the axis system actually looks like, but you don't need the vertical scale. Okay, and point A is just somewhere there. Okay, and what's happening is this particle is moving in a straight line, and it's moving in this direction here. Okay, it's got a deceleration of 4 meters per second squared, a deceleration of 4 meters per second squared. So what does that actually mean, first of all? Well, that means that the acceleration is negative because it's slowing down. So first important point to note is when you're using the equations of motion, whichever one that might be, V equals U plus AT, for example, you've got to use A is -4. Okay. otherwise you'll get the wrong answer. It's slowing down. And what's actually going to happen? Okay, well, it's going to pass here at a particular speed or velocity, 13 meters per second. Then it's going to pass here. It'll keep on slowing down. At some point, it's going to stop, isn't it? Because it's slowing down. But the question says, effectively, it's always got a constant deceleration. What's going to happen then is that it will then continue to accelerate in the negative direction. It's actually going to start going back this way. So what will happen is it's going in this direction, it slows down, comes to a stop, and then it starts going this way. How is that possible? Well, to imagine that there's something travelling this way and there's a force acting that way that is, first of all, causing it to slow down and then go in the other direction. Okay? It's as if you've got a light ball that's moving this direction here because it's being rolled, for example, and there's a strong wind pushing it that way. Well, the ball is going to slowly come to a stop and then the wind might start making it go that way. And that's what's going on in this question. It's important you realise that. Okay? I might come back to that later, so I'll leave the diagram there for the time being. Find the times when the particle passes through A. So it passes through the origin at a velocity of 13 meters per second. Okay? And we're told that the displacement is 20 meters. Okay, that's enough information to be able to work out the time. Okay, we're going to have to use S equals ut plus half AT squared, so give no other information. Okay, so I'm hoping that's straightforward for you. So A, -4 because it's decelerating, and then we've got the initial velocity and the displacement. The distance between O and A is 20 meters. Okay, so S equals ut plus half AT squared. Substitute these in. So you've got 20 is equal to ut, so that's 13t plus half AT squared. So half times -4 is -2. T squared. You've got a quadratic, you've got to solve that. Okay, so you've got 2t squared minus 13t plus 20 is equal to 0. You just solve that quadratic equation. Factorise, normally they do factorise. To be honest, sometimes they don't. Okay, if they don't, then you've got a bit of a difficulty. So you could try 5 and 4, 5, 4, but that's going to give you 10 and 14. So that's not going to work, is it? You could try 4 and 5, and that's going to give you 5t. Yeah, that'll work. Okay, that's how factorisation works by inspection. Okay, so just check that 2t squared. Plus 20 minus 5t minus 8t minus 13t. Great. Okay. There's two answers. Notice in the wording of the question it says find the times. The wording is done in a very precise manner in mathematics or mechanics. Okay. When it says times, that's not a misprint. They're looking for more than one time. So you would expect 2 different times for this to happen. Okay. So you've got t is equal to, let's do the lowest one first. 5 over 2, 2.5 seconds. And you've also got t equals 4 seconds. Notice the use of the word and as opposed to or, because in this scenario, the time's taken, it will pass at 2.5 seconds and it will pass at 4 seconds, okay? Just to remind you what's happening, okay? The particle's doing this. So basically it's saying it passes A for the first time after 2.5 seconds. And then it slows down, comes to a stop, and then it starts going this way, and that's where the 4 seconds come in. So you've got to realise why those answers are coming up, okay? Because it's passing it twice, once in that direction, once in that direction there. Okay. Next, find the value of t when the particle returns to the origin. So as you can see, when it's on its way back after 4 seconds, it's already at A, so you're looking somewhere up. More than 4 seconds, aren't we? What we can do is use this equation yet again, okay, the S equals ut plus half AT squared formula, but this time just use a displacement of S, okay? Remember, displacement means distance from its starting point, okay? And because we've got O is effectively 0 and A is 20, when it returns to O it's going to be 0 again. So you've got 0 is equal to ut plus half AT squared, and you can use this yet again. Basically, negative 4, 13, 0. So we're going to have 13t and minus 2t squared. Okay, that's an easy one to factorise, of course, because you can just take out a factor of t. So you have t, and then 13 minus 2t is equal to 0, giving you two answers yet again. So 0, of course, you'd expect that because it's the starting point, the origin if you want. T equals 0, and then 2.5 seconds, and then back towards A 4 seconds, and then when it hits again, so that's going to be 6.5, is it? 13 divided by 2, 6.5 seconds. Just remember, in the context of the question, when the particle returns, okay, therefore, just write down time equals 6.5 seconds. Okay, I'm just going to underline that to highlight it. Okay, and there you go. That's well, I thought that was a lovely question, but as I said, it just threw out some really interesting things that just do need to be discussed. Okay, hope you found that really, really helpful. Okay, go practice now. Go practice. Do some questions up. Pick up a textbook. Pick up exam papers. Just you got to practice. Okay, the key thing about this in particular, but any mathematics really, is that you've got to get used to finding the equation that you need to solve your problem. Okay, and then substituting values in. Okay, so just practice and get better at it. Okay, right, thanks for watching. I'll see you again soon. Bye bye.